So this is day 40 actually on social distancing, being at home. I hope everybody's doing well and staying safe. You know, my hair was getting unruly, so my wife helped me just buzz it off, and here we are. So today what we're gonna do is we're gonna challenge you to build a water purification kit out of scavenged household items that you can find. So this video really goes hand in hand with the Instructables lesson that we created, and you should find the link in the description here. You can print it out and follow along that way, or share it as a PDF with your students. So let's just jump right into it. So a little background on the MakeWater program. My name is Ryan Beltran. I founded Alequa and the MakeWater program. And what we do is we challenge students and educators to help develop and research water purification in their classroom. We designed a kit that you can make yourself that runs the electrocoagulation process. Studies have shown the ability to kill bacteria and even remove heavy metals such as arsenic and lead. And we created the MakeWater program, where we challenge you to collaboratively improve, tweak, edit, research, and develop these kits. And with your help, we can empower communities to build and deploy better water systems, all while learning about robotics, coding, 3D printing, and STEM-related fields. What we've actually done is we took the MakeWater program and made it available for you to do at home with around-the-house items. So I'm going to show you how we made our version, but it doesn't mean you have to make it exactly the same. In fact, we actually want to encourage, and we're challenging you to create different versions and see which one has more efficiency, which one works better. And we're gonna ask that you share your findings in a survey. What I'm gonna try to do is recreate some of those that were submitted, and we're gonna see what worked, what didn't work. And we're actually gonna be doing some prizes and giveaways for those educators and students that did this and submitted their coagulator build. All right, so now you're gonna go out and scavenge your materials. So first and foremost, you're gonna need to have access to tap water. You're gonna need to have 2 clear plastic cups. You can also use glass cups if need be. Clear cups are better so that you can actually observe what's going on. You're also gonna need 2 rubber bands. You're going to need table salt. You're also gonna need to have a spare piece of cardboard, something that you can at least cut down to 1.5 inch by 4.5 inch. So for the energy source, we're gonna be using a 9-volt battery today. For the electrodes, we're going to be using 2-inch screws, but you can find screws or nails up to 4.5 inches. So we're going to need a pollutant. We're going to be using acrylic black paint. You can try to find any other sort of paint that might dilute in the water, something that will give you a visual of what's happening once coagulation occurs. Now for filtration, we're going to be using coffee filters, and if you can have 2, that's even better. We like coffee filters because they're very consistent and they catch a lot. So for the tools checklist, we're going to be using scissors, a pen, something to stir with. I have a plastic knife here, and a ruler. Now we're going to make the cardboard circuit board. We're going to be using a template that you can reference on the Instructables webpage. We're going to want to make this with this fresh piece of cardboard. And then you're going to need to draw out a 1.5 by 4.5 inch piece of cardboard. Make a slit right here down the center of the bottom. You're going to want to put a negative and a positive up here. I'm going to put the battery right here, and I'm going to make little holes that line up with these terminals right here. Cut up the center. That's good. And we're going to mark the positive and the negative on the back, just for reference. This helps us out. Now we're going to complete the circuit. And then you're going to have these screws here. Okay, so now you're going to take your rubber band and you're going to put it through this slit here. You're going to put it through the slit and you're going to wrap it twice around, going through the screws like that. So you're going to insert the 9-volt battery between the rubber bands and the cardboard so that the terminals touch the top of the screws or the electrodes. You make sure the terminals are correct, plus plus, and you're going to adjust so that it kind of looks like the battery is sitting in a chair there. Having it like this in the chair position is going to help us let it rest on a cup. And that's it. Up next, let's make some polluted water. So to make our polluted water, we're going to need paint, tap water, salt, and something to stir it with. Add about 3 drops. I'm using black acrylic paint, 1/4 teaspoon of salt, and then we're going to stir. Try not to make a mess. Get it evenly distributed in the water. This is going to simulate our polluted water. And we're going to do our first attempt at filtration. We're going to see if anything gets caught in the filter and what goes through. So you're going to take this coffee filter or whatever filtration method you have found at your house, and you're going to try to wrap it around the lip of this cup. I'm going to hold it with my hand and I'm going to start pouring some through here. The paint is mixed in the water so much that it goes right through the filter. So the filter does not catch the paint. So our goal with coagulation is to see if we can coagulate the pollutants largely enough so that they get caught by the filter and clear water comes out below. If you can reuse this filter, that'd be great. If not, maybe use a clean one for the second one. Okay, so pour everything back into the original cup. Now it's time for what we've all been waiting for. We're going to coagulate the pollutants. Now that you have the polluted water, you're going to set up the coagulator on the second cup. So you're going to balance it right here, and you're going to take this rubber band and put it around the outside of the cup, and it's going to hold that cardboard chair down. So there it goes, so that it fits right over the lip, and we are ready to pour the water in. Make sure that the terminals of the battery are touching the electrodes, in this case the screws, and then we're going to pour the polluted water in. We want to get as much of the electrodes submerged as possible, but we don't want it to go all the way up to the cardboard. I would say anything over halfway submerged electrodes is good. Now you're going to see if there's fizzing or bubbles coming from one of the electrodes. They're actually coming from both electrodes, but one should be fizzing more than the other. And I see that, so that means electrocoagulation or and I see that, so that means electrocoagulation or electrolysis is happening right now. So what we're going to do now is let this sit for a while, up to about 3 hours. Everybody's going to have a unique setup, and some might work faster than others. Some batteries might be more charged than others and might work better, and we're going to see. Now we wait and we check in on 15 to 30 minute intervals. This time lapse actually only took about 30 minutes. But once you think enough coagulation has occurred, we're going to run it through the coffee filter again. Get your second cup back again, and then we're going to add the coffee filter to the rim of that, just like we did before. Take out the electrode circuit board and put it on a paper towel or something, and we're going to pour it in again. So don't worry about filtering all the water. You're just going to filter enough to see how clear that water comes out and how much gets caught in that filter. So now we need to observe what we've done and record the results. And now take as much data, whether it be photos, video, written documentation, and fill out that survey and share with us what you came up with. So that was just our first attempt. Let's see what we can do better. Now's the time to share results, change variables, and try again. Let's really talk about changing variables, because there's so many things that you can find around the house that can do the same thing as these basic components that you saw in this video. There's electrodes, there's the energy source, there is the type of polluted water, and there's also the type of filtration. Those are 4 things that you can interchange different aspects of. And you know what? I really want to stress, if something doesn't work out, please share those results, because we can take that and we can share it and we can stop somebody else from doing that same experiment. So the good, the bad, the ugly, share everything. We're actually gonna have giveaways and prizes for those of you who have shared photos and video of your different builds. So before you go, I just want to say this is a nonprofit program, and we're really supported by viewers like you. Consider donating as little as $1 a month to help support our program. You can go to MakeWater.org. Consider subscribing so you can catch up on the next videos when we show new builds and new updates to our program. And please share this with your other educators, students, and other parents. We want to grow this out, and we think it's a really fun project that we can do with the community. So take care. I look forward to see what y'all share.